In this class, I'll be discussing about torque and angular momentum. Torque is nothing but a twisting force. Let me discuss the important concepts behind this. Take down torque and angular momentum. Torque and angular momentum. First we will discuss about torque. Torque is nothing but twisting force. Simply speaking, it is twisting force. And you've got various examples like that is the opening of door, is it not? That is a very good example. And the rotational analog of force in linear motion is moment of force. If you want to have any equivalent to the linear motion, you can mention this as what? Moment of force. So the moment, it can also be represented as moment of force. Are you able to follow? Take down. So the torque, the moment of force, also called the couple. Okay. So these are all the various terms. Now listen here. You draw this diagram. You've got the x-axis, right? Draw this x-axis, then y-axis, and the vertical is z-axis. So this x-axis is pointed above the plane of the paper and below the plane of the paper. Okay? It is almost orthogonal to each other. For instance, x is perpendicular to y, y is perpendicular to z is perpendicular to x. Do you understand this? Now, you have got a P, a point that is subjected to the torque, the twisting. And the distance between that point under consideration and the origin is r. That is the radius of the torque or circular motion. Here it is taken as a radius, and when I say radius, it indicates the position vector, so it can be represented as r vector. Done? R vector. But in your book it would have been given as bold letter. Okay, it is given in bold letter. All bold letters represent vectors only. So if I mention F, bold letter means F vector. So you have to, when you write, you have to mention the arrow mark at the top. And tau, this is called tau, the twisting force, that is torque. Now, this being a vector, this is the position vector, and this vector can be resolved into two: horizontal component and vertical component. You know, by resolving the vectors you can have, for example, if A is the vector, A cos theta and A sin theta is they are the what? Resultant, or that is the resolved vectors. Resultant vector is R. Okay, so your vector can be resolved, split into two components. What are those two components? Vertical components and horizontal component. So you have R sin theta and R cos theta. Okay, right. Now let us consider this R sin theta. And you know very well, when you have got SZ about which it is going to turn like this. So in that case, what is the torque experience? The torque experience is equal to the position vector cross the force applied on it. So the force is applied here. Okay, the force is applied here, and the Angle subtended is theta, means this is also theta. And if it is theta, now this is at the right angle because you have the vertical component and you have got the horizontal component. Is it not? And in that case, it is mentioned as tau vector. Tau vector means what? Tau is the twisting vector. That is twisting force. I can get you a best example. That is, you got some rocking thing, rocking சொல்லுவாங்கல்ல, இந்த குழந்தைகள்லாம் வந்து கிராடல்னால் இப்படி ஆட்டுறது, இப்படி இட்ஸ் அ கைண்ட் ஆஃப் கிராடல் தான். அது ஒரு டொமஸ்டிக் கிராடல்னு வச்சுக்கலாம். ஒரு இந்தியன் ஸ்டைல் கிராடல். அண்ட் வென் இட் இஸ் ட்விஸ்டட், குழந்தைங்க யூஸ்வலாக என்ன பண்ணும், ட்விஸ்ட் பண்ணிச்சுன்னா திருப்பி அப்படி ரிட்டர்ன் ஆகும்ல, பவுன்ஸ் ஆகும். That is also a kind of oscillation. Twisting is also an oscillation then. அப்போது you have got இந்த டார்க்குக்கு என்ன ஒரு ட்விஸ்டிங் ஃபோர்ஸ்னு சொல்கிறோம். அது வந்து ஒரு ரீஸ்டோரிங் ஃபோர்ஸ். அப்போ ரீஸ்டோரிங் ஃபோர்ஸ் அப்படிங்கிறப்போ இந்த இடத்துல ஆல்மோஸ்ட், ஃபார் எக்ஸாம்பிள், லெட் மீ கன்சிடர் an axis like this. If it is twisted அப்படின்னா about which axis? Suppose if it is z axis, it is twisted like this. Okay? Are you will follow? Right? Okay. And this angle is the theta. Twisted angle. So when it is twisted, it will restore to the original position. So the tau is equal to, and how long? For example, you have got a shortest r and where the torque will take place, and assuming that now the point of attachment here and it makes a long twist, is it not? So in this case, you know very well the position vector, that is r, is also very important here. Okay, so therefore tau is equal to r, and it should be called cross, that is vector product. Take down the tau is equal to tau. This is called tau. Tau vector is equal to this r vector. What is this r vector? Position vector cross, and you got the force vector. So this is called cross product. What do you call it? Cross product. Let me compare this with the W, where you got force vector dot displacement vector. Here it is a dot product. A dot product results a scalar, correct? Whereas a cross product results a vector only. Okay? You know very well, if it is a dot product, F vector modulus, S vector modulus, and then cos theta, is it not? But what about this? If it is a tau vector, then r vector modulus f vector modulus sin theta, and you have to put the n cap also here. That is the unit vector about which it is going to turn, the axis of rotation. Okay, that is in n cap. For example, this the perpendicular. So this is the plane. It is going to twist, means the perpendicular axis to the plane, okay, is called n cap, and we take this as a unit vector. So it should be r vector, and r modulus, you know very well, this can also be represented as a scalar, okay, magnitude. And what about this? Magnitude of modulus of s vector means s. So similarly you can mention this as r and f, then you have got sin theta into n cap, unit vector. So that is tau vector. You must believe that this is scalar whereas this is vector. Okay, so that makes the difference. So please make a note of it. So when it stands 1, you can call it simply tau is equal to r f sin theta. Okay, take down. So r f sin theta. Here, what is r vector? What do you call r vector?
Position vector.
Very good, position vector. So don't forget this, position vector. And what about F vector? That you know, the force vector.
of
Okay, right. And what is the moment of force and its a dimension? So note this point. The dimension. Dimension of force. What is dimension of force? You know very well, F is equal to what? MA, correct? So M means capital M, that is the dimension. What is A? LT power minus 2. So it has the MLT power minus 2 dimension. And this is into the moment, is it not? And therefore it should be what? ML square, because into the R, is it not? R, you have got the position. For position, it's a kind of length parameter, length dimension only. So in that case, R into F. And sin theta is after all an angle, it has no dimension. Do you understand this? So what is the torque? That is the dimension of torque. Dimension of torque is equal to, what is that? You have got already ML squared. Now ML squared T power minus 2. Good. Next. What is the SI unit for this? For torque. We already declared torque is equal to, what is that? RF sin theta. Forget about the sin theta, you have got RF. So F is Newton, R is meter. So Newton meter is the what? The SI unit. Okay. Right. So now let us go for momentum. Take down momentum. What do you mean by simply momentum? In linear momentum, first let us discuss the linear momentum. We will try to understand this. Then we will go for the angular momentum. What is linear momentum? Anyone? What do you mean by momentum? Mass into velocity. It is represented by P. So you can call it P is equal to mv. Is it not? So P is equal to mv. Here P is directly proportional to m, as well it is directly proportional to v. So P is equal to mv. So in the case of angular momentum, take down angular momentum. Angular momentum. That is given as, that is L is equal to, when you say L is equal to R cross P, where L is also vector, that is the angular momentum. Take down angular momentum. R is the position vector and P is the linear momentum here. Do you understand? So it involves the linear momentum. Do you understand this? So L vector is equal to R vector cross P vector. Okay. Again, you can expand this. Is it not? R vector modulus, then P vector modulus into sin theta n cap. N cap taking unity, you can leave it as sin theta. So L vector is equal to this much. Therefore L vector is equal to, what is that? R magnitude P magnitude into sin theta. Is it not? Take down. So RP sin theta. Okay. What is theta? Theta is the angle between R and P. Is it not? What is theta? Is the angle between R and P. That is, R is, what is that? Position vector, and P is the momentum, linear momentum. Now we can have various cases in both. For example, even here as well as here. Based on theta, you can have various cases. Suppose if theta is equal to 0, what will happen in this case? Tau is equal to, what will happen? Sin 0?
0.
So no torque. No angle, no torque.
Sin theta 0.
Okay. Suppose if it is the maximum, that is 180, what will happen?
180.
If it is 180, theta is equal to 180, 90. When theta is equal to 90, 1. Therefore, tau is equal to, is a product of R and F, force only. Okay. So similarly, you can apply the same concepts here, the cases, right? And then, if it is 180, that is also 0, is it not? Because sin 0, 0, sin 180 is also 0, right? Okay. Now let us discuss the physical quantities of moment of force and angular momentum. Okay, take down. L is equal to, have you noted down all those things? Right. Now let us discuss about the physical quantities. L is given by R vector cross P vector. Okay. Now let us differentiate with respect to T. D L vector, you have to put L vector compulsorily. L vector divided by dt. So I am differentiating. What do you mean by differentiation? Difference in the shortest interval of time. For example, what is the angular momentum in 1 hour? Instead of saying 1 hour, what is the angular momentum in 1 second? Instead of saying 1 second, what is the angular momentum in split second? 0.001. 0.00001. So infinitesimally very small interval. That is called the shortest interval of time, and that is always called the spontaneous changes. So all spontaneous changes can be studied as differentiation. Okay. So differentiation with respect to the shortest interval of time, the change taking place in the shortest interval of time. dl vector by dt is equal to, and d by dt of r vector cross p vector. Please make a note of it. Okay. Now there is a rule called the UV rule, the product rule in differentiation. That is, when you have got two variables and when it is differentiated, so it becomes what? That is UdV plus VdU. It means that is you have to maintain the constant, one of the variables as constant, the other variable should be differentiated. Likewise interchange. Okay, then add it. So that is called the product rule. Okay, take down. Product rule. So you can apply this logic. Why? Because these two are variables, and when you differentiate this should also be differentiated. Okay, so please make a note. So therefore, now this dr vector divided by dt cross p, I am maintaining p as constant. Okay, and then close the bracket and put plus. Now r vector is made constant, and you have to differentiate what? dp divided by dt. Do you understand this? Okay, got it?
Yes, sir.
Now we know already the P is equal to mv. What is this P? Momentum. M mass, V velocity, P vector means mv vector, because m has no vector, it's a magnitude, mass. So v has vector, so P vector is equal to m vector, m into v vector, okay. And we know already what is the v vector, the position, change of position vector, any displacement, correct, divided by dt, am I right? So instead of dr by dt, you can put this v, is it not? So I can introduce here P. Therefore, you have got, what is that? This is v vector, is it not? Okay, so I can mention this as v vector. Take down. Why? Because dr by dt is equal to v vector. Got it? Into cross P. P vector. This is also P vector, P vector. Okay, always mention the vector. Right? Now, this dr by dt cross P vector, okay, that is also represented as, what is that? That is, this can be represented as P is nothing but mv, is it not? Okay, so, and you have here dr by dt is nothing but v, so we have v, because dr by dt is equal to v cross, okay, vector cross, and you have this P vector, okay. So this is equal to, okay, dr cross dt, dr by dt cross P, as well v. This v, we can once again replace this by mv, because P is nothing but mv. Therefore v cross m v vector, okay. So when you cross two identical vectors, it becomes 0. Therefore it is 0. Do you understand this point? Okay. Therefore this becomes 0. Do you know why? So we have the explanation here. Okay. Why? Because we already know. When you put, see, we have got v vector and you have got another mv vector. Magnitude wise it may be changing. But when you put like this, you will put vr vector, v vector modulus, again m into, we will put v vector modulus into sine theta. This sine theta is equal to sine 0, theta is equal to 0. Why? Because it is coaxial, it is collinear. There is no angle between that. It lies on the same vector. It means what?
0.
0. Okay, so that is why it is 0. Do you understand this point? Right. And then now dp by, take down, dp by, so I have talked about only this aspect. Okay, now we have another one. So you can put this as equation A. Now we have to talk about B. We already proved that A is equal to 0. Okay, now let us proceed with the B. This dp by dt, I am talking about this. Let me take B. What is that component B? Or I am going to discuss about r vector into dp vector divided by dt. Now I am going to discuss about this. Okay, so let us have this dp by dt, right? Take down dp by dt. dp vector divided by dt. dp vector divided by dt is equal to, it is given by f vector. It is given by f vector. Okay, please take down. And what about these two vectors? These are collinear, or since it is m, you can call it as parallel vectors also. It will be like this. Okay, so you can mention this as parallel vectors because it is m multiples. For parallel vector, the cross product is 0. Please mention that one. For parallel vectors, the cross product is 0 because theta is equal to 0. So sine 0 is equal to 0. Therefore, it is 0 ultimately. Now we have dp by dt is equal to f. And Now multiply by r vector on both sides. So r vector into dp vector divided by dt, and you have r vector cross f vector, and we have got already this r vector cross f vector, okay, that is nothing but tau, torque. Right? So dt by d by dt of r cross p. What is this r? Position vector. What is this p?
P vector.
P vector. What is that p vector? Moment, linear momentum. That is given by tau. Okay, that is given by tau, and therefore we have got this as a dl by dt already. Therefore dl by dt is equal to tau. Okay. Therefore the time rate, that is the rate of change of angular momentum of particle, is equal to the torque. Now if we have n number of particles, because we cannot say only with one particle, these are all concerned with the one particle. Suppose if we have n number of particles, what will happen? So for example, let us have the system of particles. Okay, take down. For a system of particles, how many particles? N number of particles. It can be 1,000, million, 1 lakh, etc. So for n number of, for a system of n number of particles, what is angular momentum? That is represented as capital L. Now each particle will be having its own angular momentum, is it not? For example, you have got some point of twist here, and this is A. It is going to be twisted like this. So each particle will be having a twist, is it not? Okay. So it means L1, for example, for point mass 1, M2 for L2, M3 for M3, you have got L3. Likewise, n number of particles are there. They will be experiencing the angular momentum, is it not? And that is represented as L1 and L2 and L3, etc. up to Ln. And this can be simply represented as a sigma, a summation, is it not? So L is equal to summation sigma starting from 1, I is equal to 1, and ends n. So L put I. Now what is the angular momentum of second particle? L2 is equal to R2 into P2. Do you understand? Similarly, what is the ith angular momentum? Li is equal to R vector. You should put R vector, P vector. So R, always put this vectors. Okay, don't forget this. So Ri and Pi. Okay. What is Ri? The position vector of ith particle. Very good. And with respect to a given origin. So the origin is O with respect to a given origin. And what about Pi? Linear momentum of ith particle. Okay. Yes. Now we know already L, angular momentum, is given by vector. Angular momentum vector is given by summation of, we can simply put Li, is it not? Okay. That is equal to summation of I Ri vector cross Pi vector. Okay. So this is the generalized definition for angular momentum. Please make a note of it. Now, our next step is we are going to differentiate once again. So, we have got this equation. Let me write once again. What is that equation? Li, that is L, is nothing but, what is this equation? Summation of
RA into P.
Ri vector cross Pi vector. Okay. Now, let us differentiate once again with respect to T. With respect to T. Therefore, dl divided by dl vector divided by dt, that is equal to di by dt of what? And this can be simply represented as Li also, is it not? This is I. So in that case, di by dt of summation of Li, is it not? Okay. So we can take this as summation outside being a constant and put dl by dl vector divided by dt, right? And this differentiation of this one is nothing but tau, is it not? So this is nothing but the tau. Okay, tau of I, of, you can put vector and with I. Okay, so dl vector divided by dt is given by summation of ti, tau I. Okay, what is tau I? The torque experienced by the ith particle. Please make a note. Torque experienced by the ith particle. Therefore, tau I is equal to Ri cross Fi, that we know. Okay, what is Fi? Force experienced by the ith particle. And when we have actually, this is the sum of two forces. Okay, so one is Fi, take down Fi external, right, in order to cause the vector, and the other one is Fi, what is that? Internal. So you can split this into two. Actually, this is the sum of both external and internal. Done. Therefore, tau is equal to, right? Tau is equal to, what is that? The sum of, similar to the external and the internal forces. So, tau vector I, and then, or you can put external, simply speaking external overall, plus tau vector internal vector. Okay, so this is the total vector. Now if you are very particular about the external, you can mention as external vector. So can you write this one? Can you write the tau external? What is that tau external? Can you tell me? Tell me. Sum of total. We are talking about the total one, because external I put individual, I have made it total now. So tau external is equal to sum of what is that? Ri vector cross then, very good. So tau external adhe appdiye reproduce paniko. Okay, tau external. Okay, got it? Inga tau varadu f external, Fi external. Okay, can you write down for tau internal? Tau internal, that is sum of Ri F internal, Fi internal vector. The vector la poradhu marandradhu. Okay. Therefore, we can finalize this as dp by dt. Take down. What is this dp? Change in, what is that?
Linear momentum.
Linear momentum divided by dt is given by,
F vector.
that is nothing but f is equal to ma.
M.
That is f, and in this case external. For example, f is equal to ma. What is ma? mv minus mu, change of momentum in a given time, correct? And what is this mv minus mu? P1 minus or P2 minus P1 divided by T, which is nothing but dp by dt, is it not? So that is equal to f. Okay, and that is why in this case dp by dt is equal to f external. So you can mention this one also. And this is for major difference, but for the shortest interval of difference you have to introduce the spontaneous. What do you mean by spontaneous? In a split second it has taken place. Okay, right? So in the next class we will explain how it is used in the conservation of angular momentum, how it can be applied, and how it is governed by conservation of angular momentum. So we will discuss in the next class. And there are some problems based on this. You please make a note of it.